Hello. So we've started to learn about equations. You've done a little bit of work about it with equations. You've looked at whether something is a solution to an equation or not. You know about a few different parts of the equation. Today we are going to start using equations. We're going to see how equations are used in actual situations. And one of the most important things that equations do is they illustrate relationships between values. And there's a couple of different relationships that exist, and one is linear relationships. We're going to do linear relationships today and tomorrow on this video and the next one. Today's linear relationships will have to do with proportional linear relationships. Tomorrow, or in the next video, we are going to look at proportional or non-proportional linear relationships. We're going to look at situations, tables, and equations, all of which will be illustrating these types of linear relationships. And we'll talk about what it means to be proportional, and we'll touch on what it means to be linear. Okay. So, first, we're going to start with a situation. Okay, here's our situation. 4 boxes cost $8. This is called a rate. A rate it's an amount with 2 units. So in this case, we have boxes and money, dollars, and that's what makes this a rate. It is a single rate because it's 4 boxes cost $8, and it is an amount 4 and 8, but with 2 units, boxes and dollars. How much does 1 box cost? Well, if 4 boxes cost $8, then to find out how much 1 box would do, we want to go from 4 to 1. How do you go from 4 to 1? You divide by 4. So 8 over 4 turns into 2, so our answer is $2 per box. Now, this was a rate. 4 boxes cost $8. $2 per box. This is still a rate, but it is a unit rate. And the difference is that the second unit has the value of 1. $2 per box. How many boxes? 1 box. So that's why this is a unit rate. Okay, so you have a rate, 4 boxes cost $8. The 2 units are boxes and dollars. How much does 1 box cost? You do $8 divided by 4 boxes equals $2 per box. Notice how in both cases it's boxes over dollars. Okay? So now, complete this table. Well, every box cost $2. So 0 boxes cost $0. I don't have to put the dollar sign because it's already there in the table. I'll talk about these being X and Y in a moment. 1 times 2 is 2. Another box, you have 2 boxes, so that would be 2 plus 2 is $4. Plus another box makes 3 boxes, makes 4 plus 2 is 6. 4 boxes cost $8. That's already there because it told us up here that 4 boxes cost $8. 4 boxes, $8. 5, so I'm adding another box. I'll add 2 more. 8 plus 2 is 10. Excellent. Notice this last box is empty, and that's on purpose. I'll talk about that in a moment. So there's a couple of ways to go about this, and we'll talk about them in a moment. Look at this table. and find where all of these 2's are. Just as an interesting little artifact. See where all of these 2's are. Now notice this 2 is not that 2. But there are 2's here. We'll talk about those in a moment. All right. Now we have to write the equation. Well, you know that this is x and y, right? X's, by the way, are the first one, and y's are the second one. Boxes are first, it's x. Dollars are second, it's y. X, y. So, 0, 1, 2, 3, 4, 5, and then I want to know, what if this was x? What if this was x? Well, what do we do to 0 to get to 0? Well, almost anything, really. What do you do to 1 to get to 2? We multiply by 2, right? This is times 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. So we did this times 2. 0 times 2 is 0. 1 times 2. 2 times 2. 3 times 2. 4 times 2. 5 times 2. What are we going to do to x? We're going to multiply it by 2. What's x times 2? 2x. And that is what y is equal to. So the equation is y equals 2x. And that's as simple as it can be. Essentially what we're saying is, here's x. X is this first value, boxes. Here's y. Y is this value, total cost. To go from x to y, all we have to do is multiply by 2. All right. So, as you can tell, it's pretty straightforward, fairly easy. This is exactly the same page, but I just want to examine k for a little bit. How much does one box cost? Well, we know that that is $2 per box. Complete the table. 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10, x, 2x, equation, y equals 2x. As you can see, the relationship hinges on the number 2. 2 is important for this. 2 is the number that forms the linear relationship, the proportional linear relationship. It's very important. It is so important that mathematicians have given it a name. And the name that they've given it is k. We're going to find all the places here where k is. Where is that number 2? We're going to make a k list. All right, well, first of all, first k. Here it is, $2 per box, right? Well, what is that called? That is called a unit rate. So our first entry for what k is unit rate. Excellent. Where's another 2? Well, not this one. That's not an actual 2 in this case. But one box cost $2. Here's one box. Here's $2. So that is y, it's the y value, because there it is, the y value, when x equals, I just put an x when I wanted to put an n. Rewrite. When x equals 1. So wherever you see 1, underneath it, in the y value, will be k. All right. Where's another place? Well, here in the equation. There it is. What's that called? What's the number called that multiplies the variable? Starts with a c. It's the coefficient in the equation. I don't have to write in the equation. There's only one coefficient on this page. It's the number that multiplies x. Well, that's what we're talking about. We're always going to multiply. So, there's another place where 2 is hidden. Here's 1, but that's not what I'm talking about. We kind of already did that, because this is really this one over here. It's really the same one. There's another place. I kind of hinted at it when I did how I filled in the table originally. How do you go from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10, well not 10 to 2x, 2x doesn't have a value. Oops, get rid of that arrow. How do you get from those to those? You add 2, add 2, add 2, add 2, add 2. This is called a common difference. Common difference. And those are some of the different things that k is. It's the unit rate, it's the coefficient, it's the common difference, 0, 2, 4, 6, 8, 10, 12, 14, 16. It goes by 2's. It is when x is 1, what is y? And it's what multiplies. It's the unit rate. Okay? Let's try a different one. Here is a different situation. 4 boxes weighs 5 pounds. How much does 1 box weigh? Well, remember, we had to do 8 divided by 4, the second amount divided by the first amount. It's actually, that's another thing that k is. It's y divided by x. So, here I'll show you. 10 divided by 5 is 2, 8 divided by 4 is 2, 6 divided by 3 is 2, 4 divided by 2 is 2, 2 divided by 1 is 2, 0 divided by 0, you can't divide by 0, 8 divided by 4 is 2, so we're going to do 5 divided by 4. You know what 5 divided by 4 is? It's 5/4. Now, since we're asked for an amount, we actually want to give it as a mixed number. I know, horrors, isn't that awful? We have to use an evil mixed number, but you kind of have to. If I tell you to put out 5 4 pounds, people would be confused. You really want to write it as 1 1/4. 1 1/4 what? 1 1/4 pounds per what? Per box. Easy. Complete this table. 0 times 5/4 is 0. 1 times 5/4 is 5/4. I could write that as 1 1/4. It doesn't make any difference. 2 times 5/4 is 10/4, but that simplifies to 5/2. 3 times 5/4 is 15/4, which doesn't simplify. I could turn it into a mixed number. It just won't. I don't bother. 4 boxes is 5 pounds. That already says that up here, so I don't need to do any calculations. 5 times 5/4 is 25/4, which again doesn't simplify. So what did we multiply each time? So if this is x, then this is 5/4 x. Y equals 5/4 x. See how simple? Once we know the unit rate, 5/4, that's what k is. That's what you multiply to finish the table. Then you put it right here in front of x and you've got your equation. It's really that simple. Let's start with a table. 0, 0, 1, 20, 2, 40, 3, 60, 4, 80, 5, 100. What did we multiply by? 20 is right. And in fact, 1 is 20. So how many cookies are in one box? 20 cookies. Per. Undo. Per box. 20 cookies per box. That's how much. What is the equation? Well, what is k? K is 20. You know that. K equals 20. So y equals 20x. See if that works. 5 times 20 is 100. 4 times 20 is 80. 20 times 3 is 60. 20 times 2 is 40. 20 times 1 is 20. 20 times 0 is 0. Y equals 20x. Let's start with the equation. Y equals 3/2 x. Well, how many cups of mashed potatoes make one serving? Well, this... Oops, I don't want to do that. Let's use a highlighter. This is k. K is the unit rate. What's the unit rate? 3/2. What's 3/2? 3/2 is 1 1/2. So 1 1/2 cups per serving. Yes, I want you to have the per in there so it looks like a unit rate. Per serving, yes. All right, let's multiply. 0 times 3/2 is 0. 1 times 3 halves is 3 halves. 2 times 3 halves is 6 halves, but 6 halves is 3. 3 times 3 halves is 9 halves. 4 times 3 halves is 12 halves. Or 4 divided by 2 is, see, remember how to multiply fractions? 4 divided by 2 is 2. 2 times 3 is 6. 5 times 3 halves, 15 halves. And so on. See how easy? The equation tells you what K is. You just turn it into a unit rate by making it a mixed number. Cups per serving. How do I know it's cups per serving? Because it says cups and serving. Easy enough. Okay? Aspects of linear relationships. So just to review before we talk about these. If you start with a situation, find the unit rate by dividing. Complete the table by multiplying all the x values by the unit rate. Simplify the fractions when you can. Write y equals kx, k being the unit rate. You've got your equation. If you start with a table, find 1, that value is k, so that's the unit rate. That's a 20, so it's 20 cookies per box. We know it's cookies in boxes because it says cookies in boxes. The equation is y equals that number x, y equals 20x. If I start with an equation, whatever that number is next to x, whatever the coefficient is of x is, that's k. So just turn it into a mixed number, cups per serving, because it says cups and servings. Fill in the table by multiplying each number by that. 1 times 3 halves, 2 times 3 halves, 3 times 3 halves, 4 times 3 halves, 5 times 3 halves. You know how to multiply fractions by whole numbers. I taught you how to do that earlier. Okay, let's take a look at all of these. Let's look at the equations in each one. Here's the equation y equals 5/4 x. The only operation is multiplication. Y equals 20x. The only operation is multiplication. Here's the equation y equals 3 halves x here at the top. The only operation is multiplication. So, one aspect. 1. In the equation, the only operation is multiplication. I had to get very small there to be able to fit it. 2, let's look at the tables. All right, here's the table. Notice it's 0, 0, and then it has a common difference. Here's this table, 0, 0, and then it has a common difference. It goes up by 5/4 each time. Here's this table, 0, 0, and then it has a common difference. It goes up by 20 each time. So, 2 aspects of the table. In the table, 0, 0, that's x, that's y. X comes first in the alphabet, it comes first in the ordered pair. 0, 0, and it has a common difference. If it doesn't have a common difference, it's actually not linear, but it's certainly not proportional. Now let's look at, let's just look at the situation. There's the situation, 4 boxes weighs 5 pounds. That's the only information we're given. How many cookies are in one box? 20 cookies in a box. How many cups of mashed potatoes to make 1 serving? So the situation is, it only has a unit. Well, it actually could have a non-unit rate like the first one did. It only has a rate. And that's it. And it starts with 0. Starts with 0. And that's the entire business of proportional linear relationships. Okay.